Ooh, nice. My name is Iris. Sorry, Leandro. My name is Iris. I'm originally from Austria, but I've lived in Sweden for the last 4 years or so, and I've lived kind of all over Europe a little bit. I work as a software engineer, and I'm also a board member of SOURCE, SRC, the Stockholm Research Center, where we try to advance humanity through technology. And as a software engineer, I deal with bugs on a basically daily basis. But how do we find them? This is a thing I invented yesterday, the bug finding pyramid. Most of your bugs you want to, in an ideal case, find before you go live. So you want to find them either through automated or manual testing or other tools that help you find bugs early on. Some of them will slip through, that's always the case. And then if you have good monitoring systems, they can actually alert you right away before too many users are impacted. The worst case, the highest part, and the reason why I put it up there is because percentually only very, very few bugs should get into this stage, should actually be discovered by users complaining on, Twitter, to your customer service, what have you. So we're building our code for our customers, not for ourselves, right? So we should never actually affect them. And I believe the best way of preventing bugs is to actually invest in those bottom layers a little bit more. And that's what I'm going to talk about, and not only that, but more specifically about front-end testing. Because it turns out 36% of us are still not testing their front-end applications, according to this study that came out this year. So people still have this notion that front-ends are harder to test or don't need testing. So I want to kind of work on that a little bit. But before we start and dive into the tests and the bugs, let me introduce some ground rules. There are a lot of things that tests should be. They should be writable, readable, fast, isolated, and so on. But I think the most important rules, for me at least, or the most important questions that I ask myself before I write a test are these two. Number one, will the test fail when something goes wrong? It sounds pretty obvious, right? If it doesn't fail, why did you even write a test? But it's important to think about that, because you can, from that, derive which parts can go wrong in which ways, and those are the things that you want to actually write tests for. The second question is a little bit weirder. Will the test only fail when something goes wrong? And I'm bringing that up because tests are also code, right? You also have to maintain those. If you write tests that constantly keep failing and you need to refactor them, change them every single day just to deliver your software, you stop writing tests, you'll stop trusting in your tests, and that's not good. What we can derive from that second question is, what is the public interface to be tested? As long as you test that part, you should be safe with not having to refactor it too often. All right, everything good so far? And let's jump into the first bug, okay? Users can't change their addresses. This is basically what happened. My colleague introduced or changed the name of a flag. In my branch, I just started using that flag. And because of that, that button that you see down there was just not rendered anymore. What could have helped with this? Well, a lot of different tools could have actually helped that. You don't even need to write a test if you have the proper tooling in place. Really, what was happening was somebody was lazy, and rather than defining which prop type should be passed in, was just like, oh yeah, this is an object, right? Had we used something like TypeScript, we could have gotten an error or something like this, right? So great. But even with proper prop type validation, either when you try your code out in a browser or while running other tests, you would at least see some error messages like this. Will these tests fail when something goes wrong? Yeah, pretty much. Will the tests only fail when something goes wrong? Broadly speaking, yes. There are some exceptions, but for what they do on a very basic level, we should be fine. Then another one, filter not updating. We have this notification setting in our application, and the user clicks on it. Oh shit, it didn't update. What happened? Being a front end, I was like, backenders. They probably forgot to do something, didn't do their work, right? Turns out now it was our fault. And what we have somewhere in our application is this data field, and there's the flag filter enabled, and that thing wasn't being updated correctly. How could we test for that? Unit tests. Unit tests test like one piece, one unit of your application in isolation. In this case, that unit would be this toggle filter function. It takes an old state, some ID, and produces some new state. The cool thing about that is it's a pure function. I see people taking pictures, I'm very happy. The great thing about these pure functions is that no matter how often you call them, given the same input, they will give you the same output. There are no side effects, there's no funky business anywhere. They are really easy to read, they're easy to understand, even months down the line, right? So this also, if you don't have a lot of these in your application, consider refactoring a little bit. And another reason why I like them is because they're really easy to test. Because really, you just call that function, pass something in, and you look at the output. This is what a test could look like. Here we're using chest. In the beginning, we just set up some data beforehand, then some data that we expect afterwards. Mind you, we were updating the filter flag here. We then actually call the function, and then in the end assert that they're both the same. Pretty easy. Will the test fail when something goes wrong? Yep. Will the test only fail when something goes wrong? Unless the business logic changes, yeah. And if the business logic changes, I think it's fair to also update your tests. But you might be wondering, front-ends aren't all just pure functions, right? What about other UI problems? I have another bug for you. Forever a loader. Be quick. So our users were greeted by this on the start page, and they started reaching out to customer support saying, the page doesn't load, I only see this loader. Turns out that this was a really busy month for us, and our servers were in the best condition because we had so many calls that just a lot of them failed. Not ideal, but for a period of time that was the case. Turns out that what we were doing is this. We had an is loading and returned the loader, and then is there an error and return an error. Unfortunately, the error happened while loading, and so we never reset the is loading state, and because of that, users would just see that annoying loader. Now, if we look back to this function, turns out React components don't actually look that much different from that. You have some properties, and you return a React element, and for our purposes, you can think of them as a pure function, I think. So we should be able to write a test that looks something like this, right? We create an error, we render that page with that error, and also set is loading to true, because we know that that's the bug. And then we expect something to be something else, or hopefully the same. We could, for example, use enzyme and do something called mocking, where we replace the actual error page with a mock object, so that we can then say, I want to assert that this error page has been called with the error property. Will this test fail when something goes wrong? Broadly speaking, yes, but the problem is that if the error page props change, this test will still, work and not tell you that something happened. Will the test only fail when something goes wrong? If you start rendering a different error page, for example, this would fail. So you could argue that the way you present your error is an internal concern of the component shouldn't be tested. There's also another way of doing this, a little bit closer to the actual user's experience. You could go in and use something like React Testing Library and assert that the actual text of your error message appears somewhere in your rendered page. Will the test fail when something goes wrong? Yeah, technically the error could be thrown by something else, but to the user that shouldn't really matter. Will the test only fail when something goes wrong? Error page could be rendering the error differently. It could start, rendering different markup somewhere else. In that case, it would fail, although we're not updating anything. Now, a question, to mock or not to mock? Strictly programming terms here. I think it really depends. If the error page is something that you use throughout your entire project, and you can rely on that not changing or updating all too often, you can probably just mock that object and be like, yeah, that's the concern of this thing. If, however, this is more of an exception, or you're not quite sure if this is going to be something that you'll adopt everywhere, it's probably better to be on the safe side and test from a user perspective. Whenever you mock anything, you kind of get a little bit further away from the real user experience, and that's usually a bad thing. On the other hand, if you try to test too many components together, you might not be able to find bugs as easily because you don't know where the bugs are. Nice. Next one, autocomplete breaking the bank. We have this delivery set address thing, and we use Google Maps API to provide these autocomplete suggestions. It's not every day that somebody from business comes down to you and yells at you. Didn't yell, but they were like, what the hell happened? All of a sudden, our Google API cost is up like 900%. What the hell are you doing down here? And we were like, don't worry, we launched in a new market. This is to be expected. Until we found out, actually, this was rising way faster than our page views. So it turns out, the Google API has this little field called session token. You don't pay for this per request, you pay for it per autocomplete session. Unfortunately, somewhere down the line, that parameter got lost, and because of that, we were paying per request all of a sudden. Pretty bad. How could we have caught this earlier? Integration tests. Rather than just testing one component or one unit, you now test several ones in integration to make sure they work together. This is what it could look like using React testing library here. We first prepare some mocked response for our backend. So like my rule of thumb is the only thing I test in, or the only thing I mock in integration tests is the actual communication with the backend. Then we actually render our page or our component. And then, God, I hope you can read this because I can't. And then you start typing something. The reason why there's this like run all timers, it's really hard to read from this angle, is because we debounce that input. So we don't send a request on every change, we send requests on after a couple milliseconds of not typing. And then what we do is we make sure that our API was called only once, and that it was called with the right input and some string. That some string is our session token, and that we store then in some variable. And we do the same thing again, we type again, we run the timers again, and we assert it's now being called twice, and that the session token is still the same. Will the test fail when something goes wrong? Unless the backend response changes, yes. Will the test only fail when something goes wrong? Well, now all of a sudden we're relying on things like URLs, the actual structure of your HTML, maybe even translations or things like that, to be able to test. So there might be cases where you're changing translation, and because of that, your integration test might fail. You can use things like test IDs instead if you have a lot of problems with that. But yeah, I would argue that if you test from a user's perspective, that is still valuable to know that the text changed on your page. Another thing to consider is if you have a lot of that fake data that you have to provide, you can actually call your backend services and store that response somewhere using something like Poly.js, which is developed by Netflix, I think. We can also do this in a different framework, I guess, with a different library called Cypress. We're now going even closer to the actual user. We're running this application now somewhere, and the only thing we do is basically we spin up the server and actually intercept some of the calls. So for example, here we tell it on this route, return address 1 and 2. Then we actually visit the page. We type again, we make sure that the API was called, we type more, and we make sure that the token stays the same. This test has basically the same advantages and disadvantages as the last one. The one big difference is that Cypress comes with this amazing tool that lets you actually debug the tests as you go. So if for some reason you changed some text and it's failing for ominous reasons, you can actually just fire this up and see exactly what is happening. You can highlight things and see exactly where in the page are we clicking, etc. So that's super, super helpful for debugging these tests. Cool, next one, broken purchase flow. Another day, another bug. This time we get an alert because not enough users are buying our product. So we are all on call for our software as well. So somebody has to get up in the middle of the night if things happen. In this case, it was lucky not in the middle of the night, but you see the graph of the requests are okay, or of the completed checkouts. And then all of a sudden, that drops. Turns out the problem really was that a landing page that is not even owned by us was misconfigured. There was a missing slash in the URL, and because of that, people just couldn't get into the checkout. It wasn't even our problem. It was just there was no link to the checkout. So after our postmortem, as I explained before, we do these to make sure these things don't happen again. This team decided to, on one hand, improve the validation of that field to make sure there's always a slash in there, but that still doesn't prevent other typos. So what they then did is that they started running this special kind of tests after each change for all markets that the change is applied to. And the tests they wrote are end-to-end tests. And end-to-end tests are actually kind of similar to the integration test that I showed you, just that we don't want to fake anything anymore. We want to run these in a production or production-like environment to make sure all conditions are pretty much the same or the exact same as for a real user. Now we just click through the app. So the Cypress integration test from before, if you want to make it an end-to-end test, basically what you do is you just instead create a real user and visit the real website. So in this case, it could look something like that. We start by creating a user and logging that user in. And the way we do this, these functions are in a library for us, so they're shared between different teams because everybody can use these functions in their end-to-end tests. We then make sure that there's a Start Now text on that page, and we click the Purchase call to action button. We then make sure that we get redirected to the checkout URL, and that there's a way of entering your payment details there. And you then press Start My Free Trial. And then we again make sure that we landed on a different page, on the purchase confirmation page, and that all the data there is correct as well, and that they're confetti displayed to our users. The really nice thing again about Cypress is that although this is like all synchronous, it actually waits on each step to wait for this condition to be true. And if it's not met within a timeout that you set, it will fail at that point. So you don't need to explicitly assert. Will this test fail when something goes wrong? Yeah, if anything bigger is actually broken, these tests are usually pretty reliable at finding them or catching them. Will the tests only fail if something goes wrong? That's a little bit the problem that I think a couple of people have already alluded to with end-to-end tests. They can be quite flaky, especially if you don't run them in a production environment, but only in a production-like environment. You'll oftentimes have errors because, oh, the user service is down, and because of that, all of a sudden nothing works and no end-to-end tests run at all. So you have to really invest a lot of time into creating a system that you can run them in reliably. They can also take a lot more time than unit tests to run. So that's another thing to consider. We don't run them as part of our CI/CD pipeline, but instead after we deploy. So we still have some safety, but we don't pause our deploys if an end-to-end test fails because some other service is down. Now we've talked about functional bugs and other UI bugs. What about visual bugs? This might be my favorite one because after all I'm a front-end developer. This button is haunting me, honestly. I wake up in the middle of the night checking if it's above that fold or not, And I've pushed it up again so many times, but it never stays up there. It always comes down again. And how can you make sure that it stays above that bar? One way of testing that would be through snapshot tests. A snapshot test is basically you render a React component and then save that to a file. And then on consecutive runs, it will render that again and compare it to the contents that you've saved the last time. These files get a little bit long. This particular one is like 1,788 lines for one page. And that is exactly where the problem lies, I think, with these. Will these tests fail when something goes wrong? Yeah, sure. Will they only fail then? No, they fail all the time. And what I've seen, it's true, what I've seen in my team is that people just start ignoring them because there's just so much to look at. I mean, GitHub basically says, don't look at this, right, by default. So once you see these kind of things, you wonder, is it actually valuable to have these if people start just ignoring them? I personally don't think so. So my recommendation with snapshot tests is store the snapshot not in a separate file, but directly in your test. That helps you actually keep them short. And you can, for example, you can store diffs of different things in a snapshot rather than storing the entire file in a snapshot, right? So keeping them short helps a lot. Is there a better way of doing this, though? I think yes, visual regression testing. So it's basically the same idea as the snapshot test, just that rather than storing the HTML and CSS output somewhere, you store a screenshot. And that means that you take a screenshot before and after and compare visually. For us, we do this as part of our just normal CI pipeline. And you just see an overview of all the components that have changed or have been updated since, or how they differ from master. You can also look at it in this view, where you can, blink between them, slide between them. There are 100 different ways of configuring it, but it's super, super handy for seeing what has changed visually in your application. And that has given us a lot of confidence, especially when it comes to design system changes and things like that. And we've built this ourselves because of our, own build tool that we use. But you can use something like Loki or Storyshots, or you can also build your own using a library like Backstop.js together with Cypress or Puppeteer. Will these tests fail when something goes wrong? Again, like all snapshot tests, right? Yes, they will. Will they only fail then? No, they will also fail all the time. But in this case, we actually have something that we can very easily compare with our eyes. And it's way easier to look at pictures for us than it is to look at lines of code that have changed. Sorry to say, but even as a developer, that's still the case, right? One problem with these is animations. You can't really have animations and compare these screenshots. So what we did is we enabled, we have a flag for disabling all animations when we run these. Can we take questions afterwards? Cool, thanks. Where do we take it from here? First of all, I hope that I could show you that testing frontends is really not as daunting a task anymore as it used to be. And there's a lot of tools out there. They're all very, very well documented. And there's really no excuse not to test anymore. The only thing that you have to do is decide which tests to write and get doing it. How do you decide what to write? I personally like to think of those two questions that I introduced, maybe read a couple more blog posts, and then find whatever works best for you. It really depends on your piece of software, what you're writing, what kind of test coverage you want to achieve. And the most important thing is that they have to give you good confidence. So maximize that effort to confidence ratio. In the end, we write tests to have the confidence that our software is not buggy and that we're delivering good value to our users who are paying us for this, right? So I feel that we owe it to them that we have that confidence. Thank you.
Questions? Thank you for the great talk. So I have two small questions. First one about how much time usually developers spends on writing tests, integration, different end-to-end, or everything. And the second question, because you said that some of the tests, like result testing, may fail. In that case, you have some failing tests. Do you check them manually? Are they result tests or something less? Or so you need to push the production servers. How do you manage that?
Okay, so the first question, let's start with that one. Can you repeat it real quick? There's a lot to process.
So how much time usually a developer spends on writing tests?
Yeah, I think it really depends. Again, if you want to put a lot of effort into this, if you have a critical application that deals with user data, for example, banking applications, I don't know, those should be tested really, really well. So they're putting a lot of effort into getting the best quality out to your users is really, really important. If you just build a blog, probably don't spend too much time on this, right?
Yeah, it's clear. So the question, do you have any statistic in your company, for example? So do you have that, for example, 40% of their time they spend on writing tests?
That's interesting. I've not measured it myself for our team. I can say for myself personally, probably around 10% of my time, sometimes 20, depending on, we've had problems with our flaky end-to-end tests, for example, so they take up quite a lot of time. But yeah, between 10 and 20% for my particular application. But again, it really depends on what you're developing. And then the second question.
The second question, so how do you see the broad tests are failing, and how do you ship new code to production?
Yeah, so we only take our unit and integration tests and run them in our CI/CD pipeline. And tests that are prone to be flaky are marked as flaky. So they are retried, things like that. But that's mostly true for our end-to-end tests. So because we don't run them in actual production, but in a production-like environment, we run into these problems. And we spend quite a lot of time actually going through them. It takes a process, right? So we have a goalie as well who takes care of making sure that all incoming requests to the team are answered. And that's also the person who would, in stand-up, bring up, oh, this test is failing. I'm going to work on this and fixing it today. You had a question as well, right?
Okay, thank you for a nice talk. So my question is related to visual regression testing.
Yeah.
How do you cover scenarios when you do some request backend and show data UI kind of? Is there a way to wait until data comes then?
So I would think, or I would say, if data is coming from the backend, you might not want to test that integration in that test, but instead you might want to run that test on your component library, for example. So what we do is we use Storybook, and each one of our main pages has a story. And they just receive mock data, right? You can use data from the actual backend to fill that component with data, but that for us is the safest way. So there's a little bit less that we have to take care of, and one source less that could change and cause our tests to fail.
So you are mainly using that kind of test for design systems?
No, it's not a design system in this case, but it's we test our React components on the front-end side with this, instead of the interaction between the front-end and the back-end.
Yeah, thank you.
So, thank you.